BERT. Reading in both directions. Part 0. Why this paper exists. This is Part 0 of our deep dive into BERT, Pre-Training of Deep Bidirectional Transformers for Language Understanding, the paper that fundamentally changed how we build natural language processing systems and made pre-training the dominant paradigm. This part is about why this paper needed to exist in the first place. What problem were they solving? What had been tried before? And why did their solution matter so much? By the end of this session, you'll understand the context that made BERT feel revolutionary, not just incremental. Let's begin with the abstract. Back in 2018, if you wanted to build a system that could answer questions, classify sentiment, or understand language in any meaningful way, you had a choice to make about how to use all that unlabeled text data sitting on the internet. There were two main camps. Camp 1, feature-based approaches. These models would pre-train on massive amounts of text to learn useful representations, then extract those representations as features and feed them into task-specific models. Think of it like learning a useful vocabulary first, then building different machines for different jobs using that vocabulary. Camp 2, fine-tuning approaches. These models would also pre-train on lots of text, but then you'd take that same pre-trained model and adapt it directly to your specific task by continuing to train it on your task data. It's more like taking a generalist and specializing them through experience. Both approaches were showing promise. The abstract specifically mentions ELMO, a feature-based approach, and GPT, which represents the fine-tuning direction. But here's the critical limitation the paper is pointing at. Despite the progress, the strongest language representation models of the time weren't deeply bidirectional during pre-training. What does that mean? A lot of models were trained to read text left to right. Each word could only see the words that came before it, not the words that came after. That's intuitive for language generation, predicting the next word, but it's a constraint for language understanding. Think about the sentence. The bank by the river was flooded. To understand what bank means here, you need context from both sides. Not just the before it, but river after it. A left-to-right model builds its representation without that full right-hand context. Some models tried to patch this by training two separate models, one left to right and one right to left, and combining them later. That gives you bidirectional signals, but it's not the same as a single model jointly conditioning on both directions throughout every layer. So you had a fundamental trade-off. Either you get deep representations but only one direction at a time, or you get both directions but without a single, fully integrated bidirectional model. The solution? The researchers asked a radical question. What if we could pre-train deep bidirectional representations, where every layer of the model sees context from both directions at once? They called this model BERT, which stands for Bidirectional Encoder Representations from Transformers. The core innovation is in how they pre-train. Instead of predicting the next word left to right, they randomly mask out some words in sentences and train the model to predict those masked words using context from both sides. That forces the model to build genuinely bidirectional understanding from the ground up. And structurally, that changes everything. Because BERT learns these deep bidirectional representations during pre-training, you can then fine-tune it for a wide range of language understanding tasks by adding just one simple output layer on top, without redesigning the model for each task. Want question answering? Add a layer. Want text classification? Add a layer. Want named entity recognition? Add a layer. The pre-trained bidirectional core does the heavy lifting. And the paper pairs this with a second pre-training idea about sentence relationships, which we'll cover later. But the headline in the abstract is this shift to deep bidirectionality. Why it matters, the results. The paper reports that this wasn't just elegant in design, it was empirically dominant. On GLUE, the General Language Understanding Evaluation, a collection of 9 different natural language understanding tasks, BERT achieved 80.5%, a 7.7-point absolute improvement over the previous state of the art. On multi-NLI, a natural language inference task where the model has to determine if one sentence follows from another, BERT hit 86.7% accuracy, a 4.6-point improvement. On SQUAD version 1.1, the Stanford question answering dataset, BERT achieved a test F1 score of 93.2, improving by 1.5 points. And on SQUAD version 2.0, which includes unanswerable questions and is harder, BERT scored 83.1 test F1, a 5.1-point improvement. These weren't improvements on one narrow benchmark. This was 11 tasks across different kinds of language understanding, and the same pre-trained model delivered state-of-the-art with minimal task-specific modification. The abstract sums it up perfectly. BERT is conceptually simple and empirically powerful. Simple because the idea is clean. Pre-train deeply bidirectional representations, then fine-tune with minimal changes. Powerful because it worked across everything. So at a high level, the abstract is telling us the old world had strong feature-based methods and strong fine-tuning methods, but deep, fully integrated bidirectionality during pre-training was still missing. BERT flips that. Deep bidirectionality becomes the foundation, and task-specific complexity drops dramatically. Now, if you're thinking, okay, but how do you train a deep bidirectional model without it just cheating and looking at the answer? You're thinking like the authors. Part 1 is where they make the case. We'll walk through the introduction and the core innovation, masked language modeling, how it enables true bidirectionality, and why previous approaches fell short.